Hello everyone and welcome back. If you've been following along, you'll know that I'm interested in building a robot that is capable of helping me sort coins for my coin collection. In the last video, we were talking about my new Bamboo Labs Carbon X1 3D printer and some of the things that it could do. But in that video, I also mentioned that I really have no real-world experience using a 3D printer, and I obviously have some pretty elaborate plans for it. But since I don't know what I don't know, I wanted to try and print and build a few designs created by other people in an effort to get comfortable with the limits and tolerances of 3D printing in plastic. And I figured I'd get a few bonus points if I ended up creating something as complex as it is completely useless. So stay tuned if you'd like to see what I came up with. So in this video, I'm going to attempt to print and build this 7-segment display counter created and distributed by Fluibles. This is by far the most complicated thing I could find to build, and even the instructions say that it is not recommended for beginners. But I've never let a little thing like lack of experience slow me down. So let's just jump in with both feet, shall we? So I paid the $8 or whatever to download the STL files for this project, but given the amount of time that must have gone into the design, the clear amount of over-engineering involved, the more than 100 parts that needed to be printed, and the 26-page instruction manual that comes with it, I think that's really an amazing deal. And again, this video is not sponsored. Overall, printing the STL files took a long time. I completely filled each build plate with parts, and each of those took approximately 5 hours to print. So with setup, and trying not to annoy my wife by printing things in our tiny apartment when she's trying to sleep, that represents about 3 days of setup and printing. But even though it took a long time to print the parts out, the 3D printer performed flawlessly, and I didn't really have any other issues with the actual printing of the parts, especially after solving the noob issues I mentioned in the last video. The one thing I will mention about the design is that the gears that drive the actual segments had very important alignment marks on them that did not print out very well, even at my printer's best resolution, which I believe is a 0.2 millimeter layer height. Since you need to use these marks to properly set up the entire mechanism, these marks should have been made clearer on the finished gear. In fact, I think those calibration marks could be through holes so that they become even clearer to the builder. Also, printing the part numbers on the actual part would have been helpful, but I just used a Sharpie marker on them before removing them from the build plate. In my opinion, 26 pages for the instruction manual isn't quite enough to do this build justice. I think the instruction manual could have been expanded to about 50 pages in order to make the form and function of many of the parts much more clear to everyone beyond the original designer. For a newbie like me, it was really pretty difficult to understand how all the pieces fit together, how they should be aligned, how they needed to actuate, and how important it was to have every subassembly aligned so that you could get the correct sequence of gears set up so that the segments count in the correct order. Now, the instruction manual is fairly clear about how to put most of the major assemblies together, but most of those assemblies are put together with very specific screws called out in the appendix. And I'm not sure if this is more global supply chain issues or what, but as it turned out, those specific screws are currently very difficult to source. It said that we needed a 1.2 millimeter by 8, and said that the length really wasn't that important. But even with that leeway, I was unable to find the screws online. Not with a quick Google search, not on eBay, and apparently not even on Amazon. I ended up purchasing screws that I thought would work on eBay and others on Amazon, but those all ended up being too big. These larger screws kept cracking the PLA plastic, and I had to keep using Gorilla Super Glue to put the pieces back together. The process was a bit frustrating, but it eventually kind of worked, and I could get it to somewhat hold together. In a lot of cases, I ended up just gluing parts together that probably should have been screwed together, and I'm not sure I'll be able to get this back apart later if ever needed, but hopefully that won't be an issue. I built my unit with a manual hand crank, and as you turn the crank, you can see that it wants to move through the entire count sequence, but because there was a lot of sticking between the plastic parts, in a lot of cases, the parts do not move freely enough, and that means a lot of these segments do not actuate freely. Now in the instruction manual, they address that issue and asked that you use a hand reamer to ensure that all of the parts turn freely on the small nails we're supposed to be using as pivots for many of the plastic mechanisms. I don't have a hand reamer, and I didn't find one that was the right size to purchase, but I was able to use a small Phillips screwdriver that came with my computer repair kit, and that seemed to work pretty well, until of course I put the whole thing together. Now I was particularly careful to make sure that all of the pieces rotated freely, but I think I could have been a little more thorough with my cleaning up of the gears to ensure that all of those rotated freely as well. Despite my best efforts, the plastic parts were not free enough to be actuated by the plastic springs called out for in the plans. So I tried to design even stronger springs to help snap the segments into position with a little more oomph. But as you can see in the finished product here, that didn't really improve matters much. You need to manually push the segments forward and back to actually see the numbers that the unit was trying to display. But as I turn the crank, here you can see that the counter actually does count from 0 to 9, but again, because the segments don't actuate freely, I need to manually pull them forward or back so you can see what's going on. Now this is fine for my purposes. I mean, I was really only doing this as a proof of concept to test the tolerances of 3D printing, and it gave me a good baseline to work from, so that I can see I need to loosen up the tolerances a bit in my own future designs. I've also seen in other 3D printed parts that the creator often leaves room for a bearing to ensure that the parts spin smoothly, so that's something that I should also consider in my own designs. Any parts that need to rotate or spin will probably also need either some sort of lubricant that doesn't eat plastic, or they'll need a bearing to reduce friction. All in all, I'd say this was a successful failure. I learned what I wanted to know by putting this all together, and it really was a great learning experience. Again, I think it was a great test case for my eventual, perhaps even more complicated robot designs. In the next video, I'll show you some of the revisions I made to my own robot design. In the meantime, maybe you'd like to check out some of my earlier videos and see what all this is about. Please subscribe and hit the notification bell if you'd like to see where this is all going. But until next time, that's my 2 cents. Thanks for watching, everyone.